Good morning, children. Welcome back to our math session. Today we are introducing a new chapter, that is chapter 9, Algebraic Expressions and Identities. And today's topic is Introduction Part 1 with exercise 9.1. So let we start. Let we start our new chapter, Algebraic Expressions and Identities. Topics to be covered in this lesson are introduction, algebraic expressions, terms, like terms and unlike terms, factors, coefficient, type of expressions, that is monomial, binomial, trinomial and polynomial, addition and subtraction of expressions, multiplication of expressions and identities of expressions. So let we start. Let's look at some real life examples, get an idea about what are algebraic expressions and why did we need them. Let's say that you have some number of chocolates. Now we do not know exactly how many chocolates do you have, but have some number of chocolates. And let's say that your little brother has two less than yours. That means he also has some number of chocolates. And only we know is that the number of chocolates with your little brother is 2 less than what you have. Okay. So how would you express this fact mathematically? You can definitely say, you write it in English that my little brother has chocolates 2 less than that of me. But how do you express it mathematically? Okay, have you do not know the real number of chocolates that you and your little brother are having, right? So what we do? Let's assume that you have X number of chocolates. We have just assumed. Then how many chocolates your little brother has? Here your little brother has X minus 2 number of chocolates, right? So what is this X minus 2? This is nothing but algebraic expression, right? Here X is a variable. X can take any value and you do not know how many chocolates you and your brother had, isn't it? Therefore, we made use of the variable X. So you have assumed that you have X, then your brother have X minus 2. That is 2 less than X. Let's think of another example. Let's say that whatever you scored in your exam, your friend scored twice than that of you. So how would you express this mathematically? This means you scored, let's say that X. Then your friend would have scored 2X. That is 2 into X. This 2X is nothing but an algebraic expression. Clear? Now, did you get an idea about what are algebraic expressions? Yes, these are those expressions which may have constants like 2. It will have some other mathematical operations like plus, minus, multiplication, division, etc. It's also include variable like x. And all of these together make algebraic expressions. Clear? So what is an algebraic expression? A mathematical phrase with a constants, variable and operations. Yeah, operators. It's include how we have phrases in English. In maths also we have phrases, because in every time it is not convenient to write sentences after sentences to express facts. So we need these expressions which in brief would be able to convey the same information. Now what are these things? Means this constant, variable and operations. First let's see constant. Well, constants are those values whose values would always remain the same. So let me give you some examples. Let's say that 1, 2. So what are these? These are numbers, isn't it? These are constants because 1 will always remain 1. 2 will always remain 2, right? It has a fixed value like as 3 upon 2, again a constant. 5.6, it also again a constant, because these all are having their own value, means it's have a fixed value. So this is called a constant. Next, variable. So variables are those whose values keep changing depending on where they are. For example, X, Y, Z, P, Q, R, A, B, C, etc. So generally we denote variables with the alphabets. Okay. So now what do we mean by keep changing their values? Here we already told that variables are those whose values keep changing, isn't it? So let's take one example. Yeah, some examples of expressions. For example, x plus 4. This is an expression. What is 4? The value of 4 would always be in constant. That is 4 itself, isn't it? So that is for 4 is a constant. What about x? The value of x could be 1. Then x is equal to 1. Then the value of this expression is 1 plus 4. That is 5. Then the value of x could be 2. The value of this expression will be 2 plus 4 is 6. If we give the value of x is 0, then 0 plus 4, that is equal to 4. Like that. Okay. So, x can take multiple values. Therefore, x is a variable. Clear? And what else these expressions contain? It contains operations like plus, minus, multiplication and division. So these are all operations. So when you look at this expression x plus 4, it has variable which is x. It has a constant that is 4 and also has an operation that is plus. Let's look at some more example. 3x minus 9 upon 2. Is this an expression? Yes, it has constant. It has variable. It also has operations like minus and division, isn't it? Now 10x. What do you think about it? Is this an expression? Yes, this also a combination of variable, constant and operation. 10x means 10 into x. 10 is a constant, x is a variable, into is a operation. Okay. Now one important thing to be noted here, that when I say that an expression should contain constants, variable and operations, it is not mandatory that an expression must contain in all of these. So you have something like this x. So x is also an expression. It doesn't have any operation. It doesn't have any constant. But did you think it's an expression? Yes, it's an expression, because x is what? X is nothing but 1x. That is 1 into x. So 1 is constant, x is variable and into is an operation. Right? So any expression which has evidently have a constant and an operation, but it is still an expression. Okay? So this is called algebraic expressions. Clear? Next point is terms. Terms are added to form expressions. Terms themselves can be formed as the product of factors. Parts of an expression formed separately first and then added. That is called terms. This each part is called a term. For example, 3x square plus 4y. There the terms are 3x square is one term and 4y is another term. So how many terms are there? Two terms are there in one expression. Same way, next example, 2x plus 3y plus 1. There three terms are there, 2x, 3y and 1. Clear? Now next, like terms. Like terms are those terms which have same algebraic factors. So what do we mean by that? Let's take an example. Let us suppose you have an expression 3x square plus 4x square plus 5. Now, if you observe this expression very closely, what are the terms? So the first term would be 3x square, right? Second term is 4x square and third term is 5. So there are 3 terms here. Now out of these 3 terms, which are the terms with the same algebraic factors? So as I said, factors, when you look at 3x square, what are the factors? 3 is the numerical factor and algebraic factor is x square, that is x into x, right? They are the algebraic factors. In second term, the factors would be 4 and x square, that is x into x, right? 4 is the numerical factor and x square is the algebraic factor. So if you compare these two terms, 3x square and 4x square, both are same algebraic factors, right? Because both have x square as their algebraic factor, isn't it? So therefore 3x square and 4x square, these two are like terms. Clear? So let me give you some more examples. So here the like terms are 12x, x minus 25x. These are all like terms. Why? Because all of them have x as their algebraic factors here, isn't it? Whereas when we talk about unlike terms, terms with different algebraic factors. For example, if we compare minus 25y with minus 25x. So in this case, both have the same numerical factor, isn't it? Minus 25 is there. But their algebraic factors are different. Therefore, these two are unlike terms. So, the numerical, if wherever the numerical factors are same or different, that doesn't matter. But if their algebraic factors are same, then like terms. If algebraic factors are different, then unlike terms. Similarly, if you compare 12 and 12x, these are again unlike factors. Clear? Now what is a factor? A factor is one part of a product, isn't it? A factor is one part of a product. For example, in the term 8x, the factors are 8 and x. Like as term ABC, the factors are A, B and C. 12x, 12 and x. Both are factors of the term. 3x square, 3x and x. X 2 times are there. 4x square, 4x and x. Clear? Like that. Now what is coefficient? A coefficient is a number multiplied by a variable. For example, in the term 8x, the coefficient of x is 8. What number is multiplying with the variable? That is the coefficient. That is also called a numerical coefficient. Clear? Next point is types of expressions. That is monomial, binomial, trinomial and polynomial. According to terms, we can divide the expressions. That is first monomial. By name only we can say that mono means one. So monomial means an expression with only one term. That is called a monomial. Example, 6x, 7pq, xy, 9xyz, 4bc, etc. Binomial, by, two. Two terms are there. An expression which contains two unlike terms, not like terms, unlike terms is called a binomial. Example, 4y minus 3z, x cube minus 2, pq plus 1, etc. Trinomial, an expression which contains three unlike terms is called a trinomial. Example, 4y plus 3z minus 3, x square plus 6x minus 2, p plus q plus 1, etc. Now polynomial, expressions that have more than two terms with non-zero coefficients and variables having non-negative integral exponents are called polynomials. Means simply more than two terms, that and all are having more than two unlike terms. Okay. So 3 we can say that trinomial, but more than 2 and more than we can say that it is a commonly telling polynomial. Okay. So here in this case you can see that here one number one expression is given here, 5x square plus 2y plus 9xy plus 4. You can see that here 5x square, only 5x square is there, then it's a monomial. If 5x square plus 2y, then it's a binomial. 5x square plus 2y plus 9xy, then it is trinomial. If all together means 5x square plus 2y plus 9xy plus 4, that is called a polynomial, or it is called an algebraic. Totally it is called algebraic expression. And here you can see that what is coefficient. First term 5x square, 5 is the coefficient, 2y, 2 is the coefficient, 9xy, 9 is the coefficient, and 4, only 4 is there, that is a constant. Now what are variable here? Here x and y are variables. And next topic is addition and subtraction of algebraic expressions. When we are adding or subtracting two algebraic expressions, we can only add or subtract like terms. The sum of two or more like terms is a like term with a numerical coefficient equal to the sum of the numerical coefficient of all the like terms. Similarly, the difference between two like terms is a like term with numerical coefficient equal to the difference between the numerical coefficient of the two like terms. Let's see some example. First one, add 9xy square and 8xy square. Here 9xy square and 8xy square both are like terms. So we can add the coefficients of both, that is numerical coefficients numbers 9 and 8, means 9 plus 8, that is 17. So the answer is 17xy square. Add the coefficient, keep the variables and exponents on the variables the same. Now second, subtract 10y square minus xy square minus 17y square minus xy square. First step, only like terms can be subtracted, isn't it? So in this algebraic expression, like terms are 10y square and 17y square, like as minus xy square and xy square. So 10y square minus xy square minus 17y square minus xy square. Now second step, subtract the coefficients of like terms. That is 10y square minus 17y square minus xy square minus only 1 xy square is there, isn't it? So 10 minus 17, that is 7 y square. Here minus plus, one is plus xy square, one is minus xy square. That will cut it down there and 0. So the answer is minus 7y square plus 0 is equal to minus 7y square. Here 10y square minus 17y square. So minus 17 is greater. So minus 7y square will come. So the answer is minus 7y square. Clear? Okay. So let's start our first exercise, that is exercise 9.1. First question is, identify the terms, their coefficients for each of the following expressions. Question number 1, 5xyz square minus 3zy. What are the terms? The terms are 5xyz square and minus 3zy. Then what is the coefficients? 5xyz square, the coefficient is 5. The numerical coefficient, that is the number 5. So 5 is the numerical coefficient of first term. Then minus 3 is the coefficient of minus 3zy. Second question, 1 plus x square. Terms 1, x and x square. And their coefficients all are having 1. It is also only 1. X square is also only 1. Now third question is 4x square y square minus 4x square y square z square plus z square. Here terms 4x square y square minus 4x square y square z square and z square. And their coefficients, first 4, second one minus 4 and third 1. Now question number 4. 3 minus PQ plus QR minus RP. The terms are 3 minus PQ, QR minus RP. And the coefficients are first one 3 itself, then minus 1, 1 and minus 1. Now fifth question. X upon 2 plus y upon 2 minus xy. The terms are x upon 2, y upon 2 minus xy. And their coefficients 1 upon 2, 1 upon 2 and minus 1. Now last, sixth question. 0.3a minus 0.6ab plus 0.5b. Terms are 0.3a minus 0.6ab and 0.5b. And their coefficients 0.3 minus 0.6, 0.5. Okay. Now second question. Classify the following polynomials as monomials, binomials, trinomials. Which polynomials do not fit in any of these three categories? First one, x plus y. X plus y is a binomial. Two terms are there. Next, 1000. 1000 is a monomial. Only one term is there. X square plus x cube plus x raised to 4. That is a polynomial that do not fit in these categories because more than 3 terms are there. 7 plus y plus 5x. 3 terms are there, so trinomial. 2y minus 3y square. 2 terms, so binomial. 2y minus 3y square plus 4y cube. 3 terms, so trinomial. 5x minus 4y plus 3xy. That's also trinomial. 3 terms are there. 4z minus 15z square. 2 terms, so binomial. AB plus BC plus CD plus DA. 4 terms are there. Means more than 2 terms. So that is a polynomial that do not fit in these categories. PQR. Only one single term. So monomial. P square Q plus PQ square. 2 terms are there. So binomial. 2P plus 2Q. Again 2 terms are there. So binomial. Now question number 3. Add the following. In addition or subtraction we can do in 2 methods, that is horizontal method or direct method and column method. In horizontal method, first we have to make the like terms together and see the coefficients of the variables, expressions. Then add subtract the numbers. So let's see the first question. A minus BC, BC minus CA, CA minus AB. So arrange it as in column method, then you have to put the numbers accordingly the variable, means like terms. AB, under AB you have to do only like terms, that is coming as a variable AB itself. Like as BC, under only BC will come. And CA, under only CA. Then after that you can add. Otherwise horizontally you arrange all the like terms together. So here AB, then you can put next minus AB is there. Then minus BC, then plus BC. Then minus CA plus CA. So here all will cut down. So the answer will come 0. Now second question is A minus B plus AB, B minus C plus BC, C minus A plus AC. So here also A, if you are arranging like terms, A and last minus A is there. So cut it down. A minus A 0. Minus B, then plus B is there. So that also will cut down. Now minus C plus C, that also will cut down. Then remaining AB plus BC plus AC. That is the answer. Now third one, 2p square q square minus 3pq plus 4, 5 plus 7pq minus 3p square q square. So we can put it in column method. 2p square q square minus 3pq plus 4 write first. Then after that down, first write minus 3p square q square down of 2p square q square. Then plus 7pq plus 5. Now columnly we can add 4 plus 5, that is 9. Minus 3pq plus 7pq. Minus 3 plus 7. Positive integer is greater, so 7 minus 3, 4. Sign positive, so plus 4pq. 2 minus 3. 2 minus 3 minus 1. So minus p square q square. So the answer is minus p square q square plus 4pq plus 9. Now fourth question. L square plus m square plus n square plus L square plus 2lm plus 2mn plus 2nl. So here also L square plus L square, we will get 2L square. M square plus M square, 2M square. N square plus N square, 2N square. Remaining only one time is there. 2LM, there is no like term is there, isn't it? Like as 2MN, same. 2NL, same. So the same will be the answer. 2L square plus 2M square plus 2N square plus 2LM plus 2MN plus 2NL. And here 2 is common. 2 is coming in all terms, isn't it? So we can take 2 as common. Then you can put inside the bracket the other things. Yeah, like this 2 into L square plus M square plus N square plus LM plus MN plus NL. Yeah, otherwise same way also you can keep it like that only. Now question number 4. Subtract 4a minus 7ab plus 3b plus 12 from 12a minus 9ab plus 5b minus 3. So here also we can do in column method, arrange them as terms. Then after that in subtraction we know that in second line the sign will change, isn't it? So here 12a minus 9ab plus 5b minus 3 minus 4a minus 7ab plus 3b plus 12. So here 4a is positive, so that will change as minus. Minus 7 will change, 7ab will change as plus. Plus 3b will change as minus. Plus 12 will change as minus. So 12 minus 4, that is 8. So 8a. Minus 9 plus 7. So minus 2. So the answer minus 2ab. Plus 5 minus 3 plus 2b. Minus 3 minus 12. Both are negative, add together. Minus 15. So the answer is 8a minus 2ab plus 2b minus 15. Second one is subtract 3xy plus 5yz minus 7zx from 5xy minus 2yz minus 2zx plus 10xyz. First arrange it in like terms. So 5xy minus 2yz minus 2zx plus 10xyz minus 3xy plus 5yz minus 7zx. Here also second line we have to shift, we have to change the sign. 3xy is a positive, so it will change as minus. Plus 5yz will change as minus 5yz. Minus 7zx will change as plus 7zx. Now solve. 5 minus 3, that is 2. So 2xy. Minus 2 minus 5, both are negative, add together, minus 7yz. Minus 2 plus 7. 2 plus minus 2 plus 7, 5 minus 7 minus 2, 5. So plus 5zx. Plus 10xyz. 10xyz down, nothing is there, so directly keep it down. So the answer is 2xy minus 7yz plus 5zx plus 10xyz. Clear? Now last one. Subtract 4p square q minus 3pq plus 5pq square minus 8p plus 7q minus 10 from 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q. This also we can arrange in column method as like terms. First 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q minus 10 minus 8p plus 7q minus 3pq plus 5pq square plus 4p square q. Now change the sign. Down it is minus 10, so that will change plus 10. Minus 8p will change as plus 8p. Plus 7q will change minus. Minus 3pq will change plus. Plus 5pq square will change minus. Plus 4p square q will change a minus. Now 18 plus 10, 28. Minus 3 plus 8. Different sign, subtract 8 minus 3, 5. So plus 5p. Minus 11 minus 7. Both are negative, add together. Minus 18q. Plus 5 plus 3. Add together, plus 8pq. Minus 2 minus 5. Minus 7pq square. Plus 5p square q minus 4p square q. 1p square q is remaining. So plus p square q. So the answer is 28 plus 5p minus 18q plus 8pq minus 7pq square plus p square q.